All right, so we're still going to look at inverse functions and relations today. So we're just kind of going to go through proving whether or not two functions are inverses of each other. So you can determine whether two functions are inverse by finding both of their compositions. Okay, recall compositions had to do with g of f of x or f of g of x. So if both composition equal the identity function f of x equals x, then the functions are inverses. Okay, so you have to simplify everything down to get it to equal x. So in words here, two functions f and g are inverse functions if and only if both of their compositions are the identity function. So if we have f of x and g of x, and they are inverses, then f of g of x has to equal x, and g of f of x has to equal x. Okay, so we're just doing that composition like we did previously to see if these are inverse functions. So in our examples, we want to determine whether each pair of functions are inverse functions and then explain. So in number 1, we have f of x equals 3x minus 3, and g of x equals 1/3 x plus 4. So the first one I'm going to do is f of g of x, meaning I'm plugging in g of x for the x's in f. So like we did before, I can add that big parenthesis here where my x value would be in f. Okay, that open space, right where that x is, and I can plug in my g of x value there. So that would be 1/3 x plus 4. So from here, all I have to do is simplify. So I'm multiplying 3 into 1/3. So 3 times 1/3 is just 1, and I still have my x here. Multiply 3 into 4, so I'm distributing to get 12, and then I still have this minus 3. Okay, so I have x, and I have 12 minus 3, and that is 9. So right now I have f of g of x equals x plus 9. I still want to check what g of f of x is, just in case I did make a mistake here and somehow I ended up with just an x over in g of f of x. Okay, so now I'm plugging in f of x for all the x's in g. So I have to plug in my f of x function for this x value over here in g. So starting off my g of x function, I have 1/3. Here's where I have those open parentheses, that big space where I want to enter my f of x function. And then I have a plus 4. Okay, so now I can enter in my f of x function here. That is 3x minus 3. From here, I'm going to just simplify, so distribute your 1/3 to both terms. Okay, 1/3 times 3 is just 1. Okay, same thing here, 1/3 times 3, 1. And then I still have plus 4 on the outside here. Okay, so this one will equal, we have x, we have negative 1 plus 4, so we have x plus 3. So since both of these do not simplify down to just an x value, they are not inverses of each other. So I can actually write that out. So these are not inverse functions. Because our f of g of x equals x plus 9, and g of f of x equals x plus 3. Okay, so these are not inverse functions. So then looking at our second example, it's a little bit different. We do have a radical and a square here. So we're just doing that same process though. So we want to find f of g of x and g of f of x. Okay, so first we'll find f of g of x. So again, plugging in our g function here for the x value in f. So again, I can leave that open space where that x normally is. So here's my open space. Okay, our x value is squared in this f of x function. And then I have minus 1. So now what I want to do is plug in this g of x value for my open space here. So I have a square root of x plus 1 over 2. Now when I square a square root, those do just cancel each other out. So I have 2 times the quantity x plus 1 over 2 minus 1. Now if I have a 2 and it's multiplied into this divided by 2 right here, those cancel out as well. So I'm just left with x plus 1 and then this minus 1 on the outside yet. Now I have 1 minus 1, and that's just 0. So I do end up with just x. So now I still have to check my g of f of x, and my pen just ran out. So we're checking our g of f of x. So we're plugging in f of x for our x's in g. Okay, so I want to leave that open space there. Okay, so I have this open space where my x value is plus 1 over 2. So now within that open space, I can plug in my f of x function. So we have 2x squared minus 1. And again, we can just simplify from here. So I have this minus 1 and this plus 1. Okay, those just cancel out to a 0. So I have this square root of 2x squared over 2. Now if I have 2 over 2, again, that's just 1. So those, again, will cancel out. And I'm left with the square root of x squared. Now I have a square root and a square. Again, we're canceling. And I do just end up with it equaling x. So since both of my composition of functions end up being equal to x, these are inverses of each other. Okay, so I can say yes. These are inverse functions. Since f of g of x equals x and g of f of x equals x. Okay, so again, these are inverse functions because once you simplify both compositions down, they do simplify down to just equaling x. Okay, if they do not do that, like our first one up here, these two, then they are not inverse functions. Okay, and that's how we can tell whether or not they are inverses of each other. Okay, then if we move on to the back here, again we have some more examples. So number 3, we have f of x equals 4x squared and g of x equals 2 times the square root of x. So again, we want to find f of g of x and g of f of x. So we have f of g of x, where we're plugging in our g of x function for the x's in f. So starting our f of x function, we have 4. I'll leave that open space for my g of x function where my x usually is, and that x is usually squared. So from here I can plug in g of x. So we have 2 square roots of x. From here I'm going to simplify. Now the square, since these two are multiplied together, I can distribute my square to both. Okay, so I have 4 times 2 squared is 4. The square root of x squared is just x. Okay, now I have 4 times 4 is 16. And then I still have my x here. So right now, f of g of x equals 16x. But again, I still want to check the g of f of x value. Okay, so now I'm plugging in f of x for my g, the x's in my g function. So starting off my g of x function, I have 2, and I have the square root. And now I can plug in my x value, which is my f of x function of 4x squared. Okay, so I still have this 2 here. I can take the square root of 4 and I can take the square root of x squared. So I get 2x. Multiply my 2's here to get 4x. So since neither of these reduce down to just x, I would say these are not inverse functions. Okay, since f of g of x equals 16x and g of f of x equals 4x. Okay, so again, those are not inverse functions. They do not reduce down to just x. Okay, we're going to do one more example of this. Okay, number 4. Again, finding f of g of x and g of f of x. So starting with f of g. Okay, that means we're starting with our f of x function and we're plugging in our g of x function for the x in that f of x. So starting here, we have a 2. We have a square root. This is where our x is, so I'll leave that nice and open. And then we have a minus 5 for that f of x. So now I can plug in this g of x function where my open space is. So I have 1/4 x squared plus 5. So again, simplifying here, I have this plus 5 and this minus 5 that will just cancel out. Okay, they zero out there. So I have 2 times the square root of 1/4 x squared. Now when I have this square root of 1/4 here, I can take the square root of 1, which is just 1, and I can take the square root of 4. So the square root of 1/4 would just be 1/2. Okay, now the square root of x squared, those cancel each other, and I'm just left with x. Now if I multiply 2 times 1/2, I get 2/2, which is the same as 1. Okay, so this one does reduce to just x. So now I want to check my g of f of x function. Okay, so we have g of f of x. So this is where I'm plugging in my f of x function for my x in g. So starting with my g function over here, I would have 1/4. Okay, my x is here, so I'm going to make my open parentheses. Now that x is squared, so I need to square whatever is in my parenthesis and add on a 5. So now I can plug in my f of x function, which is 2 times the square root of x minus 5. So I want to square this. Since these are multiplied together, I can again distribute my square. If they were not, then you'd have to FOIL that out. So I'm going to distribute that square. So I still have 1/4. Okay, now I have 2 squared is 4. And then my square and my square root will cancel each other out. So I'm left with x minus 5. And then a plus 5 at the end. Don't forget that. So now within my parentheses here, I can distribute my 4. Okay, so I'm going to distribute my 4 to that x and that minus 5. So I have 1/4 times 4x minus 20 and plus 5. Next, I'm going to distribute my 1/4. Okay, so 1/4 times 4 and 1/4 times that negative 20 there. Okay, 1/4 times 4 is just 1. And I still have that x. And then 1/4 times negative 20. So that's like saying negative 20 divided by 4. Okay, that would just be that minus 5 there. And then I still have a plus 5. Now since I have minus 5 and plus 5, those zero out. And I am just left with x. So since both of these reduce down to just x, these are inverses. Okay, they are inverse functions. Since f of g of x equals x and g of f of x equals x. Okay, so those are inverses. All right, last problem here. We want to find the inverse of the function. So this is what we did yesterday, okay, just as a refresher of how to find that inverse. So we can think of this f of x as y. Okay, so just replace it with y here. Now when we're finding the inverse of a function, all we have to do is switch our x and y values. Okay, so I'm going to switch x and y, so now I have x equals y plus 1 squared plus 3. From here, I want to solve for this y value, so I want to isolate it. So to do that, first thing I want to do is subtract 3 from both sides. So now I have x minus 3 is equal to the quantity y plus 1 squared. Now I want to get rid of this square here. So the opposite of that would be to take the square root of both sides. Now when I take the square root of both sides, I have to remember to add in this plus and minus piece. So I plus and minus the square root of x minus 3 is equal to y plus 1. So now to get y by itself, I just have to subtract 1 from both sides of my equation. So I'm left with plus or minus the square root of x minus 3 minus 1 equals y. Now I don't want to leave it like that. Remember, I'm finding the inverse of f of x. So I want to write this as f inverse of x is equal to plus or minus the square root of x minus 3 minus 1. Okay, so that is my inverse. Now again, I do have you graph it over here just so you can see that reflection over the y equals x line. So if you need to make a xy chart, we have our xy chart here. I'm going to plug in the points -2, -1, 0, and 1. Okay, and again, I'm plugging these into my original because I want to graph my original and my inverse. Okay, so once I plug in -2 here, I have -2 plus 1 is -1. -1 squared is +1, plus 3 is 4. Oh, 4 here, sorry. Plugging in no, that was right. Okay, plugging in -1 now. So if I plug in -1 here, I have -1 plus 1 is 0. 0 squared is still 0. Add 3, this is 3. Then plugging in 0 for x. Okay, so I have 1 squared is just 1. 1 plus 3 is 4. Okay, and then plugging in 1 We have 1 plus 1 is 2. 2 squared is 4. 4 plus 3 is 7. And if you need to write those steps out, you can write those steps out. But now that I have a couple points here, I can make my graph. So I'll go to -2, +4, -1, +3, 0, 4, and 1, 7. Okay, and since this is a parabola, -3 here will also be 7. And I can connect each of those points. And since that was a quadratic, you do want to make sure it looks like a parabola. Now I want to plot my inverse function here. So just like we did yesterday, since it is an inverse, we're just switching x and y. So my x, y chart for my inverse, I'm just going to flip-flop these numbers. So my x value now will be 4, and my y value will be -2. My x value will now be 3, and my y -1. Same thing here, my x value will now be 4 again, my y 0. Okay, x value 7, y 1. Okay, so now that I have each of those points, I can plot those on my graph. So I'm at 4, -2. I'm at 3, -1. At 4, 0. And at 7, 1. Okay, we'll also be at 7, -3 according to our graph over here. So from there, I can connect my points, and it should look like that sideways parabola. And again, we can see that reflection over the y equals x line if I dash that in real quick here for you. Okay, so those points do reflect over that line. And you want to see that when you're finding that inverse.